Hi, for page 13 in our notebook, our goal that you should write at the top of your foldable is I can interpret graphs and draw graphs to relate to situations. The other thing that needs to happen is that you should have a cut between these two words, interpreting graphs and sketching a graph, and then a cut down here between sketching a graph and relating graphs to situations. So now we're going to open it up and we're going to start our notes. So looking in the top left corner, you're going to see this graph, and our x variable is our time. And as time goes on, you'll see that length is our dependent variable. The length is depending on how much time has happened. So to start up here, it says the length of the board decreases with time. So you'll notice here the length is this big at the beginning of this time, and then at the end, it's all the way down here. So what that hopefully means to you is you can see that the length of the board is actually getting shorter as we go. And then the length of the board is constant when it's actually being cut, and then it drops off. And then it's constant, and then it drops off when the board officially gets cut. And that continues to happen. So the length of the board is constant while you're actually cutting it. During this time, you will actually see that there are 4 cuts here. They're cutting it. There's 1, 2, 3, 4, and then there is still going to be a piece of board left when the time is over because the length never gets to 0. Looking over here, let's look at this one. This is our June cell phone cost. Our variables are independent. Our independent variable is minutes of the call, and our dependent variable is the cost. So what are the variables in the graph? Minutes of the call and the cost. So what you'll notice here is that the cost of the cell phone in June increases with the number of the minutes, the number of minute of calls. And so it looks like it's going to stay the same, but then you can tell you've gone over your minutes because then it's going to start increasing. So that by the end of it, it has increased with the number of minutes of calls. And then the cost of the cell phone in June is constant for the first part of the month. So this would mean that it's costing you the exact same thing. But then when you get here, again, that would mean that you are using more minutes than you had in your original package. So a little note is that you can analyze a graph based on the shape of the graph alone. And that is going to be the piece that you are going to need to be able to apply this to your reflection for this project. Looking here, now we're in the middle little section. So it was going to be the sketching a graph section. So when you open that tab, you're going to see that a plane is flying from New York to London and label each section of the graph. So what's already labeled for you would be like the story piece, what's happening in real life. So here's where they're taking off in New York, and then the altitude is increasing until they get to their cruising altitude, and that's when the pilot says, you may unbuckle your seatbelt, but if you're going to be sitting, keep your seatbelt on just in case we hit unexpected turbulence. So he's going constant, and then you'll see that he's going to start slowing down. This is going to be where they're telling you to get back to your seats, because the plane's going to land soon. And so they're slowing down, but everyone loves when you have to circle the airport trying to find a place on the runway. And so here they're kind of staying constant, but they have to stay up in the air. And then they finally get the go ahead. And so then they can start coming back down. And then they're landing in London. And so you'll see here is where they're landing, and so their altitude is now 0 when they get to it. So in graph terms, it's increasing. The altitude is constant, meaning they're staying the same height up in the air. They're coming down a little. Oh wait, there's no room in the on the runway for us. So they're staying at the same place, and then they're going to go down a little more, and then bam, they're on the ground and there's no altitude. So now your next one is you're going to sketch a graph of your distance from the ground as you ride a Ferris wheel for 5 minutes. And so they have distance and time, they have the minutes. And so we know that our independent variable 9 times out of 10 is going to be something that is labeled in time. So in this case, it's minutes. So as minutes go on, the height on a Ferris wheel, think about what you're doing. You're going in a circle. So if this is the ground, you're going up and then you're coming back down. And then you're going to go up and then you're going to come back down. And so your height is going to look like a graph like this. Your height goes up and it comes back down, goes up and comes back down, goes up and comes back down. And so that's what that will look like. And then a little note for you. When one quantity depends on another, the dependent quantity goes on the vertical axis. So we have talked about that a lot this year. But the dependent quantity, that's the thing that's changing. It's what depends on the x value. Okay? Looking down here, if you look at your third tab, it says relating graphs to situations. So this is going to be huge to be able to tie into the project. So when you're relating graphs to situations, this example says, suppose you pour water in a container at a steady rate. What graph shows the change in the height of the liquid in the container over time? Well, I'm saying that the answer is C, as long as the container has the same circumference. If you have a container that has the same circumference at top and bottom, then as it's filling, it's going to be consistent and that height is going to stay, it's going to increase consistently over time. If you have a funny shaped container or like a normal cup, that has like a wide top and a narrow bottom, then it's going to look something like this because it's going to speed up, but as it gets to the wider part, it takes a little longer to fill that. So it would be A if you have like a big, like a cup with a wide top and a small or a narrow bottom. And then when we look at our last one, we see that the graph at the right shows the time and distance of moving object. Which of the following situations could be to describe it? So time, again, is your x variable. Y is the distance. So we have a car traveling at a steady speed. Well, steady speed means that it's going to be a consistent slope. And since this has a consistent slope, that could definitely be our answer, but we never want to pick A without looking at the other ones, just in case we're thinking incorrectly. So on B, a cyclist slows down as she rides up a hill, speeds up as she pedals over the top. Well, this one's going to have to say that she's slowing down and speeding up. Well, if she's slowing down, her distance would still be increasing, but not as quickly. And then speeding up means that it would be increasing even quicker. C says a train slows down as it arrives at the station. Well, the distance as it's arriving to the station, it would not be a consistent graph. And in C, it says a plane accelerates steadily down the runway until it takes off. Well, if it's accelerating steadily, that means it's going to continue getting faster and faster and faster and faster. And so it's not going to be a consistent, steady speed like you see on this. So we were right to begin with. It is letter A. So these are your notes for page 13 in your notebook. When you have them all done, come up and get it stamped. Thanks.